Hello everybody, and welcome to this TransOps Solutions in Focus webinar on planning for ground service equipment at the stand. Thank you for joining me. My name is Bernard Goodworth. I'm a Senior Product Manager at TransOps Solutions. I've been a TransOps employee for the past 3 years, prior to which I worked a little over 20 years, 23 or 25, I forget now, going back, at Cologne Bonn Airport here in Germany, where I was responsible for airside planning, so all of the markings and the airside layouts. So I have had quite a bit of experience positioning and planning for ground service equipment over the years. So I hope that what I've prepared for you today will be of some benefit. We will also take a look at our TransOps tool, AviPLAN, and how one of the methods, at least, of how to apply that in your work when you're considering ground surface equipment in your stand design. To begin with, when we start planning, and our theme is the ground surface equipment, but of course, ground surface equipment operates on the apron areas. Planning your aprons and your stands. First, there are regulations that we need to follow. These regulations you'll find around the world in different locations. We have the annex, the ICAO regulations, where we, in this case, follow very heavily Annex 14. And the Aerodrome Design Manual, and around the world, many other NATO countries have their own versions which have been made legally binding of these documents. As here in Europe, the certification, specifications and guidance material for aerodrome design. And they're also here for ground markings on the aprons for the American FAA market, your advisory circulars in particular, 150, 5313A. But these things offer particular regulations with concerning demarcation of areas and minimum separation distances and whatnot, but they don't go into any detail about how to deal with ground surface equipment on location. Here you can get a better oversight of what's happening by checking up the IATA Ground Operations Manual, and in particular the supplement for airport handling, when there is a section on aircraft handling in there, which will give you a lot of tips on where to get started and where to start asking questions regarding planning of ground service equipment or movement scenarios. Or also from the ACRP, there's this apron planning and design handbook, which also has a little bit more detailed information about what to look out for when you get into such planning scenarios, including ground service equipment. The ground service equipment moves around our aprons, five basic different types of apron. Our terminal service apron, which we're going to be most heavily considering today. Also cargo terminal aprons, and here I will differentiate between general cargo and express freight services, which especially from time constraints, very, very different and need to be looked at in a different manner. Remote aprons, hangar and service aprons, as well as general aviation aprons. And general aviation and hangar service aprons are a little bit less particular when it comes to planning ground service equipment, so we won't go into that too deeply. Before you begin, I've added this diagram here on the left and give a quick introduction into apron planning and design processes. This I've taken from the ARCP document, which you saw on one of the previous slides. And why I've added this is because I find it very interesting, and actually a big tip coming from me. In this whole planning process, you'll see here from the 7 blue arrows of where you're getting your information from, 5 of those require stakeholder involvement. And so to understand what's happening with ground surface equipment, the operators need to be involved in the planning process because of the different equipment types and the different processes that and the different airlines require. It can be very unique from one to the other, and so it's very important to get this information in there. And the goal of this first step, the inventory, is to ensure a thorough understanding of the physical environment, business and operating environment also, and what things need to be considered, what equipment, and all sorts of different information that you can gather up to begin your planning process. The apron requirements here, again, we consider demands and forecasts. If you're looking at doing extension planning, maybe you're just working though on improving existing infrastructures. Either way, the goal here is to define the physical and operational, so the dimensional parameters of the geometry, which is where we bring also AviPLAN into the whole situation, and begin to develop alternatives. My old rule of thumb was always here to create 5 different alternatives from any one particular project, and from those 5 develop after quite an extensive evaluation process, always involving stakeholders, to filter out one which is going to give the optimum results at the stand with all of the necessary equipment. And then that chosen one gets refined, and then we finally go into the apron stand design, including a functional ground service equipment concept. So ground service equipment, service areas and service points. You see at any one stand, basically we're dividing it up into 2 sections. We've got the equipment restraint area to the back of the stand. So this is where the aircraft's going to move in. This yellow marked area there, where of course, when there is no aircraft at the stand, there should be never any equipment in that area, with one exception, but we'll take a look at that in a moment. The white area here, your equipment storage or staging area, and the demarcation line, which is usually just a red line. This differs from one scenario to another, one country or one guideline to another, which I'm referring to here as an apron safety line, or often known as equipment limit line as well. And so just looking at these are your main service points on the aircraft that we're going to look at today, with your getting ground surface equipment to supply 400 hertz preconditioned air, pneumatics for air starters perhaps, fuel, lavatory, and water services. When you do your stand planning though, because the ground service equipment are an integral part of the design process, it's interesting to see here, depending on your design criteria, what your goals actually are here, what this thing, whether it's a case of perhaps you're at an old terminal which has a nose load or a pedestal bridge system, so all of the doors need to be very close to each other at the front of the aircraft, which means you'll have a more spread out, as is the position on the right hand side, the right of those 2 configurations here. I've configured one with a single stop bar. You see the front door left 1 are all pretty well in a common location, but you'll also see that there's a larger distribution of service points in that type of configuration, as opposed to the version on the left, where I have optimized for something completely different. For example, here, wing location, which has, of course, its advantages when you have fixed service ports for, or fixed service pits for refueling or preconditioned air. You'll see though that the 400 hertz, the green buttons at the front are a little bit more further distributed, but not so extreme as what can happen to the rear of the aircraft because of the length of different aircraft. But I'm sure there's also optimization possibilities in both of those designs, but this is just to give you an idea of things to look at when you're going into this design process and wanting to define as common location for ground service equipment and common paths that the vehicles move around the stand. So to the beginning, I mentioned one exception here in the ERA, so the equipment restraint area. We don't want to have anything in there, but today, especially with a lot of low-cost airlines around and about, turnaround times are more critical than what they used to be. And so at particular stands where this may be a remote stand, this may be a terminal stand that also has passenger boarding bridges, but there may not be 400 hertz available on the bridge. So there will always be a GPU on the ground. The IATA ground operations manual does say here, as you see, this top text on the left-hand side extracted from the manual, where it says it is permitted to pre-position GPU inside the ERA, provided there is an assigned GPU parking position. It's always important when you do have permanent, whether they're pre-positioning locations for equipment or whether it's permanent, as it is in this case, that markings are there. It gives a great sense of security for other people who are working around, especially the pilot arriving in a position if he sees the vehicles are standing in a marked zone, that he knows that things are most probably safe, and he will proceed to move in. Also, when a marshaller or whoever else is in control at the stand at that time sees the equipment not in its position, then he can act accordingly. But here, looking at the GPU, they suggest 3 meters in front of nose wheel, 3 meters to the right of nose wheel, looking in pilot position. Here, I've done some examples based on the two previous layouts that I showed in the previous slide. Picture B here, I've got set up to the stop bar, which is a nose wheel position for each of those aircraft. And you'll see, of course, that the nose tip, depending on the aircraft type, can be a little different, probably up to 1.5 to 2 meters difference there. So, but I've checked the dimensions here, and we're between 2 and 4 meters away to the connecting point from the unit here in position B. In position C, where I've got 3 stop bars and a bit of a larger distribution of the 400 hertz connector, we're still looking at between 2 and 8 meters, which is not really a problem. It's also good when you do this sort of planning, if you're planning a fixed position like this, inquire, again, stakeholder information. What type of unit do they have? What type of cables do they have? What length of cable, maximum length of cable, are they able to use? Because there are certain situations where, depending on the type of cable being applied, that if a too long a cable is required, it can lead to voltage drop in these sorts of circumstances, which of course is not something that you want to have happen at the stand. This could lead to equipment failure or delays, or whatever. And just to show a possible advantage also of having this fixed position inside the ERA on situation D at the bottom to the center of the screen there now, you can see in gray I have placed for all of the aircraft in this configuration as suggested by the manufacturer's ACAP, so the aircraft characteristics and planning manual, and you'll see that they're also quite distributed. And so a fixed position for a situation like this does simplify the whole process at the stand, and it also makes then the maneuvering areas apart from this much easier to plan and calculate with. Also, don't forget, you see in this picture here of a GPU which is sitting in a permanently marked box to the side there, and it's connected with a cable. Don't forget these cables are always there, even if we don't see them in our CAD plans and things. These the actual connecting technologies need to be considered. The same here, we're looking at another thing that we have to consider on the ground are preconditioned air. Not offered everywhere. Also, it depends on the type, of course, the size of aircraft, what's going to happen here, but this is again why the stakeholders need to be involved in this planning process from your side, and we don't make any too many assumptions or guesses at what's happening here. The positioning and the layout of this cable, of course, this is something that could be connected to a passenger boarding bridge, not always the case. And also, as this is again extracted from the IATA GOM, where they say as a part of fuel conservation programs, most airlines, for most airlines, preconditioned air is required as long as the airport offers it, so that they can then save on fuel by not having to run their APUs the whole time. It can also be, depending on how the preconditioned air is being supplied, it can also be a noise or a fume factor at the airport or a pollution issue at the stand. Other critical things which need to be considered in the whole sequencing of arrival and departure of these different equipment types are your water and lavatory. The trucks look very similar, but they are very different, of course. You're talking about fresh potable water, drinkable water, as opposed to lavatory waste. There are regulations which demand that these two vehicles aren't at the scene at the same time. They shouldn't also use the same parking area. There are some exceptions to this. This is again why you need to involve the stakeholder, the ground operator who's doing this. And it's also a tip here from the IATA ground operation manual that water filling should take part as close as possible to the departure time of the scenario, the turnaround scenario, as possible. So here's a diagram of positioning, of a suggestion for positioning here: water or lavatory. I mean, they are interchangeable here because the connectors are not all that far apart. And depending on the sequencing time when they come, it might be preferable for some to service the water from the side or from the rear. In my experience, it's more that the water will be done from the rear because it is, as a rule, also closer. This is a 737 here that I've used for an example. And you see the water connector closer to the rear, so the water comes in from the rear. It's probably the less evasive in the whole process of turnaround because it come in from the back and then leave from the back. So it's as long as you have a good service road behind the stand, then it's less of a problem. If the vehicles have got to travel then back to the front of the stand, of course that could create a different sequencing problem. Not always the case. If you're working with a passenger boarding bridge at the front, then you wouldn't see these stairs at the back. But everything is possible here. You see in the extract from the ACAP on the top of the left-hand side here, the actual service arrangement as provided from the manufacturer actually shows the water and the lavatory vehicle side by side. as I mentioned, they can't be there at the same time. Even if they do operate from the side there, it has to be quite clear that the two are actually not meant to operate on exactly the same surface, so that there is no eventual contamination, especially of the potable water. Here's another a photo view of a water servicing unit parked in underneath the rear of a 737. When we take a look at also the equipment needed for baggage loading and unloading, again here, very important to have the operator involvement. As you'll see here, these are scaled objects in the box on the left, and you'll see belt loaders, which can be relatively small or can be quite long, especially some of these new long with bendy necks that move inside the aircraft. A little bit longer, depending on the type of operation you've got. What equipment does the operator have? This can make a big difference. And it's better to discover all of this while you're doing the planning and not once you've gone into operation. Also, even some of the smaller narrow-body aircraft, Code Cs, can be loaded with containers. So the A320 series, A319s, A320-21s, they can all be loaded with containers. So that's something to consider. They have a combination. It's possible to load them with a belt, but also with a container loader. So again, different process. Make sure you can get all information and consider these aspects when putting your design together. So here's a couple of photos that you'll see at the top left-hand side. There's an A320 being loaded with LD3 containers. That might be belly freight. That might also be the baggage in containers. It all depends on how the sorting system at the airport or that the handler's preference, what they're wanting to do. Below that, you've got a picture of a 737, which, as you see, has a completely different loading option. You see the A320, the door opens out for cargo, so they can fit the full container right up to that part of the unit. The 737, the door folds in under the roof of the internal compartment, but they can only load loose baggage or belly cargo. It all has to be done loose here. So we're looking at always a belt loader, but it could be a combination here of baggage carts, or also possible that a pallet or LD3 dolly could bring boxes which are being transported as belly cargo along with the passenger stuff. So you need to know again what things are happening, what equipment is expected, and what size of equipment is going to be expected at the stand. Refueling is a major issue in your stand design. And because you have options, again, depending on the aircraft type, underwing is possible. Again, the A320 series aircraft have a much higher wing and can be serviced as a rule from underneath the wing, whether you're talking about a dispenser as in the top photograph here, or a fuel tanker as in below. They can be serviced under the wing, and this can sometimes be a great advantage when you have stands, of course, which have a rather that are working to a minimum separation distance, for example, and you don't have a lot of traffic space between the wing tips. This can help enormously. But it can also then bring other problems with it. You'll see here then in this picture here also, as a rule, the aircraft are refueled on the right, to the right side of the aircraft from pilot's view. And you'll see here a 737 being fueled, and you'll see the truck is parked outside the wing. So this is what you would normally find for a 737, because the height is simply not there to be able to get the truck safely below. And the top picture there shows a wider body, a 787 probably there, because they are only serviceable then on the left side. some Airbus models, especially when you get to the smaller, the A320 series, also have the port, depends on the order, whether it's an optional thing, but a lot of companies still have the fueling possibility on the left for those smaller aircraft. This can also be, if you know that the airline has this option, it can relieve a lot of congestion on the left side of the aircraft where baggage loading, catering, and other things are happening in a short space of time. It can be a great advantage in your planning your scenario to be able to fuel also on the left-hand side of the aircraft. What you also need to consider with the fueling is that if it's a tanker scenario, there has to be, while the aircraft is being fueled, that the truck has to have an escape route, a clear escape route. And it's also in the operation manuals from the refuelers, it states quite clearly that if there is no escape route, then they should interrupt the fueling process. We don't want that to happen at the stand. We're talking about delays and all sorts of other problems that come along with it. This is an example of an escape route which is marked on the ground here at this particular stand. This is at Düsseldorf Airport here in Germany. They just have a simple white dashed line with a text along it and some directional arrows to show that this is the escape route. It is also, though, and I have done this myself, it's in some locations where nobody trusted that the local operators would respect this single line. So there was also a complete path marked at particular stands where it was critical because of the geometric configuration. It wasn't always possible to make sure that nobody parks equipment during the operation where it shouldn't be, to have these systems marked on the ground. The British developed or introduced what they call here interstand clearways, and because of congestion at some of their airports, they managed to stop a lot of delay codes happening because they introduced these clearways, so that there is never any vehicles parked or left anywhere along these lines or the paths marked here with the jagged